Here we'll continue on with our SAA example, side angle angle. So our given information is that we have an angle A of 20 degrees, an angle B of 40 degrees, and a side B that equals 3. So I've already begun drawing that triangle. We've got three sides, angles A, B, three angles, angles A, B, and C. And we've got the three sides that are opposite each of their corresponding letters. So I filled in 20 degrees for angle A, 40 degrees for angle B, and then the side opposite angle B is lowercase b, and that is given as 3. So let's figure out what it is we need to find in order to complete this triangle. We need an angle C, we need a side C, and we need a side A. So we're given three components of the triangle and we need to solve for the remaining 3. So you always want to start off with, are there angles that you can find without using the law of sines? And in this case you can find angle C by doing 180 minus 20 minus 40, which gives you 120 degrees for angle C. Now that we've done that, we need to find the other sides. So I'll start with side C. Now we just found out that the angle at C is 120 degrees, and our opposite side, lowercase c, means that we can write a ratio that guarantees that the variable we're trying to solve is actually in it. Now let's set it equal to another ratio where we don't have any unknowns, a pair of corresponding side and angle that are both given, and in this case that's going to be angle B and side B. So we're going to set that equal to the sine of 40 degrees over 3. We're going to cross multiply. 3 times the sine of 120 equals C times the sine of 40. Just be careful which way you divide here. We're trying to isolate the variable C, get it all by itself, so we need to divide by the sine of 40. So I'll have 3 times the sine of 120 on the top over the sine of 40, and I can use my calculator to divide it out and get an approximate value for C, 4.04. Alright, so we've gotten we've gotten 2 of the 3. We've got the third angle and we've got one of our sides. Let's find the last side. So the last side is going to be side A. So my ratio that includes that side will be the sine of 20 degrees over its opposite side A. And let's set it equal to a ratio where there aren't any unknowns. I typically like to just go back to the 2 that were given, 40 degrees and side 3. Cross multiply. And then divide to isolate the variable. So A will be 3 times the sine of 20 degrees divided by the sine of 40 degrees. And you'll want to use your calculator to approximate the value. 1.59. Okay, so you can see that it was pretty much the same thing in terms of solving the 2 angle and 1 side triangles, no matter the order that they're in. Next up, we're going to work on the ambiguous case. And the ambiguous case is more complicated than the previous 2 law of sines triangles that we've looked at. So remember, the ambiguous case is when you have 1 angle and 2 sides. And I purposely write it in that order because that's a really big reminder that you've got to be careful, that something kind of weird happens with the ambiguous case. So again, with the ambiguous case, you're given 1 angle and 2 sides. 1 angle and 2 sides. And basically 3 things can happen. 3 solutions are possible in the ambiguous case. First of all, you can get no triangle at all, or you can get 2 triangles for your answer, one obtuse and one acute. Or you can have just 1 triangle. So those are your 3 possible scenarios with the ambiguous case when you're given 1 angle and 2 sides. Essentially, the way that triangles are built, there's all sorts of rules about 3 different sides that could make a triangle or possibly not make a triangle. And the way that those 2 sides are angled and their lengths really makes a difference on whether it creates a triangle or maybe multiple triangles or maybe only 1 triangle. So in this scenario where all we have is the measure of an angle and then 2 of its other sides, it doesn't guarantee that we get the same triangle every time we build it with those given values. So we need to consider some alternative cases. Alright, so let me show you an example. And here we're going to have a side length of 2, a side length of 1, and an angle of 50 degrees. That's a capital letter. Looks a little small. So if we draw that scenario, the side across from angle A has a length of 2. The side across from angle C has a length of 1, and then angle C is 50 degrees. So notice how the angle that we're given doesn't lie in between the 2 sides. So the 2 sides are up here and the angle is down here. If this 50 degrees were put up in between, then that would be a side angle side situation, which we don't learn until the next section. So here we have 2 sides and then another angle that doesn't fall in between. So it could either be this one or this one. It could either be A or C. Alright, so if we figure out what it is that we need to find, we need an angle, we need another angle, and I wrote down the wrong side there. And we need side B. So there are 3 things that we need to solve for, 2 angles and a side. So the process of solving that is going to look a little bit different this time. Let me just resituate. Alright, so we can't use the triangle sum theorem, meaning that the 3 angles of a triangle add up to 180. We can't do that. So for the ambiguous case, here are the steps that we should follow. The first thing that we should do is we should solve for one of our angles using the law of sines, and remembering that we're going to have to use inverse sine in order to solve. So let's take a look at why. Let's say we want to solve for angle A here. So I'm going to set up a ratio involving angle A. I don't know the angle itself, that will be my variable, but I do know its opposite side is 2. I'm going to set it equal to another pair of known angle side ratios. So that'll be the sine of 50 degrees over the opposite side of 1. And then let's cross multiply and solve. So 1 times the sine of A equals 2 times the sine of 50 degrees. let's isolate our variable, but you have to keep in mind here, you can't separate the sine and the a. They're a pair. So really, to isolate that, I'm just dividing both sides by 1, which means it's already isolated. So I've isolated my variable, but I still haven't solved for the angle itself. And so remember, to undo the sine of a, we have to take the inverse of both sides. And on the left side, that'll just get us angle A all by itself. On the right side, we'll have to do the inverse of 2 sine of 50. So you do have to do an inverse sine in order to solve in the ambiguous case. So inverse sine of 2 sine 50 degrees gives me a domain error. And so when that happens, when you're unable to solve for that first angle, it means that you can conclude that you have no triangle. That these conditions that were given to us in the beginning, with this particular side, and then this angle, they actually don't form a triangle at all. So this is one scenario in the ambiguous case where you get no triangle.